In the diagram below, an 8 kg block is connected to a 4 kg block by means of a light inextensible string. A constant force of 55 newtons is applied to the 8 kg block to accelerate the combination of blocks to the right.
Thank you so much, ma'am. Oh, no, you're not done. Please read the second part of the
Oh,
statement.
the kinetic frictional force between the 4 kg block and the inclined plane is 4 newtons, while the kinetic frictional force between the 8 kg block and the horizontal plane is 8 newtons.
Okay, thank you so much, Lucy. So now it's time for me to read. So here they say in the diagram below, an 8 kg block is connected to a 4 kg block by means of a light inextensible string, which is running over a frictionless pulley, of course. A constant force of 55 newtons is applied to the 8 kg block to accelerate the combination of blocks to the right. So in other words, the 8 kg block is accelerating to the right, and the 4 kg block is accelerating upwards along the incline. But of course, it's still to the right as well. Just that it's not a perfect right because it's in 2 dimensions. But nevertheless, we can still say to the right. But a nice way is to say upwards along the incline. Okay. Now we know that if these two blocks are connected together by a string, then they're going to experience the same acceleration. That is what we know. Okay. And furthermore, they say the kinetic frictional force between the 4 kg block and the inclined plane is 4 newtons, while the kinetic frictional force between the 8 kg block and the horizontal plane is 8 newtons. Then the first question is asking us to state Newton's second law in words. Well, we are not going to do that, of course. And the next one says, please draw a free body diagram showing all the forces that are acting on the 4 kg block. And this is for 4 marks. And we know that 4 marks means 4 forces that you need to show. Even though they're only asking us to draw the free body diagram for the 4 kg, on our rough work section, we are going to draw for the 8 kg block as well, so that we know what is actually happening on those 2 blocks. And now that we have calculated, or rather drawn the free body diagram, the next question is asking us to calculate the tension in the string that is connecting the 2 blocks. Now, this is what I need you to know. In order for you to find the tension connecting 2 blocks, then you actually need to use simultaneous equations. So you're going to apply Newton's second law of motion to each of these blocks individually. And then you have to use simultaneous equations. Well, of course, you'll see that as we do it. So let's go ahead and draw the free body diagrams for these 2 blocks. Okay, I think it makes perfect sense for us to give this whiteboard a title. So we can just call it Newton's second law. That's awesome. And of course, it has to be underlined, otherwise, what's the point? Okay, so this is what we have. Now we can go, okay? So here we need to specify. Do we need to specify? No, we don't really need to. But let's specify for the sake of specifying. So even though we don't need to specify, why do we not need to specify? Well, this is because the question only said draw a free body diagram for the 4 kg block. But what I decided to do is to actually draw for both of them. So this is for the first one, okay? We know that the object is represented as a dot and the forces are represented as arrows pointing away from the dot. My pen is refusing to write. Okay, so this is our 4 kg block, and we know that it's on an inclined plane. So there's going to be a force that is perpendicular to this 4 kg block, and of course it's exerted by the surface. And we know that this force is the normal force. And we also know that there is a force that is always going directly downwards, regardless of whether you are on an inclined plane or on a horizontal plane. And of course, the name of that force is the gravitational force. We have the tension force, which is pulling this block upwards along the incline. And of course, we also have the kinetic frictional force, which opposes the motion of this moving object. So this is what we have. And of course, here we have tension, and here we have the normal force, all right? Okay. Then we need to come back and draw the free body diagram for the 8 kg block. So this is how it's going to look like. Well, once again, the object is represented as a dot. So this is what we have. But this one is on a horizontal surface. So in this case, the normal force is just going to be perpendicular to the surface as it should. And we also have the gravitational force, which is a very consistent force. And in this case, it's going to be equal in magnitude to the gravitational force, the normal force. They are equal to each other. And then we also have the tension force, which is pulling this block to the left. So this is the tension force. And then we also have the applied force, which is pulling this block to the right. So two forces are pulling the 8 kg block to the left. It's the tension force as well as the kinetic frictional force. But then there's one force that is pulling it to the right, and that is the applied force. So this is how the free body diagrams are supposed to look like, okay? Okay. So now that we know how the free body diagrams look like, then it's now time for us to calculate the tension force that is connecting these two blocks. So how can we find the tension? As we mentioned previously, we have to use Newton's second law, but we have to apply it to each of these two blocks individually, right? Okay, so this is us doing exactly as we said. So here we need to specify once again and tell them that we are focusing on the 4 kg block. And this is actually how we focus on the 4 kg block. We state Newton's second law of motion and say F net equals ma. But now the question is, which forces are acting on the 4 kg block? Well, here we only consider the forces that are parallel to the direction of motion. In other words, for the 4 kg block, we only look at the forces that are parallel to the inclined plane. We don't consider the normal force. We don't consider the gravitational force itself. However, We also know that if we have a force that is, or rather we have an object that is on an inclined plane, there's always going to be a force that is hidden. And if we forget this force, everything is going to be wrong. And this is actually the parallel component of the gravitational force, right? So that force is very important. But remember, we don't show it on the free body diagram because it's not a force itself. It's a component of a force. And a free body diagram shows the forces. So now how many forces do we have that are parallel to the incline? Well, we actually have 3 forces, okay? And we said, for the sake of convenience, for making our lives to be easy, we always choose upwards, or rather the direction of motion, as positive. Let's say that. And in this case, the direction of motion is upwards along the incline. So in other words, the tension force gets to become positive, but the kinetic frictional force, as well as the parallel component of the gravitational force, will be negative. And this is what we say. We don't know what is the magnitude of the tension. That's fine. But the magnitude of the kinetic frictional force is given to us. They said it is 4 newtons. Now, how can we find this parallel component of the gravitational force? Well, we know that by taking the mass, multiplying it with the gravitational acceleration, and multiplying this with the sine of the angle of the incline. Okay? Now, what is the mass of this block? Well, it's 4 kg. Acceleration due to gravity is 9.8. And the angle of the incline is 30 degrees. And the mass is going to be 4. The acceleration is a. Now, what is another way in which you can see that you have to use simultaneous equations? Well, it's because you have one equation, but this single equation has 2 unknown variables, which is the tension as well as the acceleration. All right? Okay. So now we just need to simplify what we have here. And remember, we have 2 methods for simultaneous equations. It's either elimination or substitution. So you'll decide on the one that you are most comfortable with. Okay. So if we go to the calculator and we say -4, and then we say minus 4 times 9.8 sine 30 degrees. Well, we simply get negative 23.6. But I'm just going to take it to the right. So it becomes positive 23.6. And I'm going to call this the first equation, okay? Then where will I get the second equation? Well, in order for me to get the second equation, I'm just going to go to this 8 kg block and I apply Newton's second law of motion once again, okay? Okay, fine. So I'm simply going to come and say F net equals MA, as I should, of course. So now the question is, which forces are acting here? It's 3 forces once again: tension, kinetic frictional force, and the applied force. The applied force is in the direction of motion, so we say it's positive. But the tension force is negative, as well as the kinetic frictional force. And everything is equal to MA. The applied force is given to us as 55 newtons. We are looking for the tension. The kinetic frictional force is also given to us as 8 newtons. And this is equal to 8A. Okay, so I want to simplify my equation. Then I say 55 minus 8. Well, I'm simply going to get 47. Then I take my 47 to the right. It becomes negative. So we have 8A minus 47. So here I can decide to use either elimination or substitution. But let's say I want to use substitution. That's fine. So here I can choose to multiply this equation by -1. So I get 47 minus 8A. And I call this the second equation. Then I'm just going to equate the two equations because anyway, they are both equal to t. So they must be equal to each other. T is equal to t, right? So here we simply say 4A plus 23.6 is equal to 47 minus 8A. And of course, we just do what we learned in grade 1, which is to collect the like terms, right? So we can take this 4A to the right, or we can take the 8A to the left. But let's take the 8A to the left because it's negative anyway. And then we can take this 23.6 to the right-hand side. So now what do we have? Well, the 8A becomes positive when it gets to the left. So now we have 12A. Now what about on the right? Well, on the right, we have 47 minus 23.6. And this gives us 23.4. And if we divide both sides by 12, then we find that the acceleration will just be 1.95 meters per second squared upwards along the incline, okay? So now that we know what is the acceleration of the system, which is the same as the acceleration of each of those blocks, then we can substitute it into any equation that we like in order to find the tension. So maybe we can substitute into the first equation. Whichever equation that you substitute, your tension will still be exactly the same. So if we say 4 times 1.5, 1.95 in fact, plus 23.6, well, we find that the magnitude of the tension will just be 31.4 newtons. So the direction of the tension actually depends on which object you are looking at. If you are looking at the 4 kg block, then the tension is upwards along the incline. But if you are looking at the 8 kg block, then the tension is just going to go to the left. And this is how you find the acceleration as well as the tension if you are dealing with a system of blocks that are connected by a string, a cable, a rope, or anything of the kind. So the last one says the angle of inclination, in other words, the angle of the inclined plane, is now decreased to 10 degrees. Now, how will the change affect the coefficient of kinetic friction? Choose between increase, decrease, or remain the same. No, the coefficient of kinetic friction will not be affected. It will remain the same. because it only depends on the type of material that the surfaces are made up of. But what is going to be affected is the normal force as well as the kinetic frictional force. How will they be affected? If the angle of the incline is decreased, then you should know that the normal force is going to increase. And if the normal force increases, then the kinetic frictional force or even the static will increase as well. But the coefficient of kinetic friction, it remains unchanged.